were the weird ones. They had a shorter period than the others, and we had to pick different intervals. Secant and cosecant kind of go back to sine and cosine. So they are more what we would expect.
Wouldn't they just be the same thing flipped?
Okay. So they are the reciprocals of sine and cosine. So yes, they're very similar here. So if I look at cosecant, cosecant is the reciprocal of sine. So I went back to doing the same points we did with sine. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sine has a high point of 1 and a low point of -1. Alright, so what is the sine of 0?
It's 0,
So cosecant would be undefined. How do we graph undefined? Vertical asymptote. Okay, what is the sine of pi over 2?
Oh, 45 degrees. No, 90 degrees. It's 90 degrees. So it'd be 1 over 0, which would be undefined.
Okay, let's slow down. I'm asking for sine of pi over 2.
0.
That is the same thing as sine of 90. So if you go to your hand trick, pi over 2, not pi over 4. So 90, sine is the square root of the top over 2. Square root of 4 over 2 is 1. So the sine of 90 is 1. What is the reciprocal of 1? 1. It's just, if you flip it, it's still 1 over 1. Okay, what is the sine of pi?
80 degrees. Or 180 degrees.
Pi is 180 degrees. What is sine? 0. So it's back to undefined. Okay, what is the sine at 3 pi over 2?
1.
Let me guess 1.
It's 1.
-1. And the reciprocal of -1 is -1. What is the sine of 2 pi?
Oh, it's going to be
0,
undefined.
Okay.
That's
So this, so far, if you think about sine, okay, the graph of sine, we started at 0, we went to 1, back to 0, -1, 0. So the graph of sine looks like this. Okay, we are graphing the reciprocal of that, which is the cosecant. However, so every time sine was 0, we get a vertical asymptote. The 1 and the -1 stay because the reciprocal of those points is still 1 and -1. Now if you think about the others, like at 30 degrees, sine is 1/2. The reciprocal of that is 2. Over here, it'd be at 1/2. The reciprocal is 2. We know with asymptotes, you are approaching them. So what it does, the reciprocal flips us away from the axis. So we are getting essentially these parabolas.
I agree.
Thank you, Megan.
So when we graph these, my suggestion is going to be to graph the sine or cosine. And that's my little green line here. That's not my final graph, but then I can see everywhere that was 0, we got a vertical asymptote. The high and low points stay, and then you just get these parabola looking things. So if we want secant, okay, secant is the reciprocal of cosine. So if we think about, you can think your hand trick, you can think your unit circle. On the unit circle, we know cosine is the x. So x starts at 1. Reciprocal of 1 is 1. Here, your x is reciprocal of 0. Here, our x would be -1. Reciprocal is -1. Here it is undefined. And then back to 1. Okay, so if we put these on our graph, so at 0, we get 1. Pi over 2 is undefined. At pi it is -1. 3 pi over 2, undefined, and 2 pi is back to 1. If we think about cosine, cosine starts at its high point, 0, low point, back to 0, and high point. So the places where it was 0, we get our asymptotes. And then if we turn this graph away from the x-axis to do the reciprocal, it's still just a series of upward and downward parabolas. It just starts in the middle of one. So both of these are just alternating parabolas, upward and downward facing parabolas. You are never hitting things between the -1 and 1. So the sine and cosine graph will probably draw in to help us, but that is not part of the final graph. The final graph is this highlighted stuff.
Came up with this.
Any questions on that? So when we graph secant and cosecant, we have to graph the corresponding reciprocal function using a dashed line or just lightly draw it in. And we'll plot our asymptotes and then we'll sketch our final graph. Last week. So if I asked you to graph y equals 2 secant of 1/2 x. When I see secant, what is the reciprocal secant?
Cosine.
So I'm going to start out graphing cosine. What is the amplitude here?
2.
Period. Okay, tangent and cotangent were different because their period was shorter, but with sine and cosine, the normal period was 2 pi divided by the coefficient of x. So 2 over 1/2 is 4 pi. How do we get the count pi?
If you divide that by 4, it's pi.
Okay, we had to do the interval on tangent and cotangent. With sine and cosine, when do you have to do the interval?
When you're adding or subtracting.
If anything is added or subtracted to your x. Does it ever hurt if you don't know if you need it? Does it hurt to do it? No, you can certainly do it when in doubt, but because I don't have anything added or subtracted, I wouldn't have to. Am I moving up or down or flipping or anything? Okay. So I'm going to start out like I were graphing cosine. So starting at 0, counting by pi. 1 pi, 2 pi, 3 pi, 4 pi. Amplitude is 2, so I'm going to mark positive 2 and -2. Okay, so cosine, let's lightly draw that in. It's not our final answer. So cosine starts at its high point, that's peak, then it comes down to the 0, down to the low, back to the 0, back to the high. I don't care if you make that dash. If that's too much dash stuff on your graph because of the asymptotes, you can just draw it lightly. You can draw the final one darker. You can erase this afterwards. You can highlight the final one. I don't care as long as I can tell the difference between this and what your final answer is, because this is kind of just to help us. It's not part of the actual secant graph. So then, anywhere this is 0, we have vertical asymptotes. So here and here. These high and low points stay. And then you are just reflecting your graph away from the x-axis. And remember, these are vertical asymptotes, so your graph is getting closer to them as time goes on. They are curved. It's like little parabolas.
Is it away from the x-axis?
Mm-hmm.
Why is the one on the right goes towards the x-axis?
The x-axis is your horizontal.
Oh, whoopsie.
Other questions there?
He looks so sad. He looks like a sad clown.
Oh.
Let's try this one.
This is a big jump.
It's a big jump. We can do it. We've done a lot of sine and cosine problems.
That is a rather decent jump.
So, starting with our list, the first thing we do is amplitude. What is the amplitude?
3 heads.
Then we do the period. Normal period of 2 pi divided by the coefficient of x, which is just 1, so our period is 2 pi. Count by, we take our period, divide by 4 for the 4 quadrants. Do we need an interval this time?
Yes.
Yes. How do we know that?
We have to
Move
subtract
right.
from the x.
Okay, something is subtracted from the x. It moved our graph to the right. So for the interval, we say 0 less than or equal to the x minus pi over 2 is less than or equal to 2 pi. So we always put the argument in between 0 and 2 pi. So then if we add pi over 2 to everything, we get pi over 2 less than or equal to x less than or equal, this is like 4 pi over 2 plus 1 pi over 2, 3 pi over 2. What else is happening on this graph?
We're moving down, up 1.
Because of that positive 1. Okay. So my first point is going to happen at pi over 2. And then we are adding pi over 2. So plus pi over 2 would be 2 pi over 2 or pi. 3 pi over 2. 4 pi over 2, which is 2 pi. And 5 pi over 2. That gives me the 5 points I need for my 1 period. If I ask for a second period, what would we need? Keep going. Keep going. 4 more points. Okay. My graph is moving up 1. So I'm going to go to positive 1. I draw in a line. That is my center of this graph. So my amplitude is 3 halves. So we will be going 1.5 above and below this line. All right. So am I graphing sine or cosine to start with?
That would be
Sine.
Cosecant, reciprocal sine. Sine starts at its 0. So at pi over 2, I'm on this dashed line. Then my amplitude was 3 halves, so we'll go 3 halves above. Back to the line. 3 halves below. Back to the line. So this is our graph of sine. Again, that's not my final answer, so you are lightly drawing this in or doing it a different color. Something. With what? Oh, yes, thank you. Okay. So anywhere this is 0, we get a vertical asymptote. The 0 in this case is our center line. So we have vertical asymptotes here, here, and here. High and low points stay, and then we turn our graph away from the axis. So we have this. So my actual answer are these little blue parabolas here. So somehow I need to be able to tell that those are different from the other. If you're confident enough, sometimes I have people that don't like to draw in the sine graph, that's fine. But you have to be able to get your points in the right spot.
I don't know what it is about coming into this classroom, but it's so hot.
Probably because I'm always so cold. I did finally turn the air on for you guys. All right, how are we doing with this? So it's just like graphing sine or cosine, and then we finish it. So why don't you guys try this one? All right, amplitude, period, count by. Interval, we say 0 less than or equal to x plus pi over 4, less than or equal to 2 pi. So if we subtract the pi over 4, negative pi over 4, less than or equal to x, less than or equal to 7 pi over 4. So far, so good? Do we have to move up or down or flip or anything? Okay. Am I going to start out graphing sine or cosine? Sine. So my first point is at negative pi over 4. When I add pi over 2, I get positive pi over 4. So, am I going to have a point on my y-axis on this one?
No.
No. Also, keep in mind, look at how far apart those points are. All of your points should be spaced that far apart. Okay, so my next one, if I add pi over 2, that would be 3 pi over 4, 5 pi over 4, 7 pi over 4. Right, amplitude is 1/2. We're graphing sine, which starts at 0. Then at positive pi over 4, we'd be at 1/2. 3 pi over 4 back to 0. 5 pi over 4, negative 1/2. Back to 0. So this is my sine graph, which is not my final graph, but I used it to get the final one. So I know anywhere this was 0, we get vertical asymptotes. High and low points stay, and then we turn it away from the x-axis. So these are the final answer, those two products. And then of course it would just keep repeating if we did another period. Is that okay? All right. What if, let's try this and then we'll probably stop for today. I want an equation. So let's start by thinking about sine or cosine. So if this had a vertical asymptote, we know the original one was at 0.
Yeah, which is 1.
This would stay here, back to 0, here. So is this a sine or a cosine?
Sine.
So the reciprocal of sine is? Okay, so I know it's a cosecant. What is the amplitude here? 1, because we go 1 above or below on my sine graph, so there's nothing out in front. Is it flipped or anything?
Nope.
Nope, so I don't have to worry about that. All right, then period. How long did it take before this started repeating?
4 pi.
4
Okay, so we need to think about how we find period. We do 2 pi divided by the number in front of x, and it had to equal 4 pi. So 2 pi has to equal 4 pi b divided by 4 pi, so b is 1/2. So it's y equals cosecant of 1/2 x. Is that okay? B. What do you notice first? We've got one at point at 2 and one at 0. The middle is right here. So the original went up 1. So we have to have a plus 1. Okay, so this would have been at the 0 mark.
Amplitude 1.
Alright, so is that a sine or a cosine?
Cosine.
It's a cosine?
FPC.
It's a sine.
Uh-huh.
Because it started on its 0.
Yeah.
So reciprocal of sine is? Okay, what's my amplitude? Above and below this, we just went 1, so we don't need anything else in front. Okay, this one is a little bit weird because what's happened to our graph? It went left. Okay. So a couple ways you could do this. One, if we think backwards from our interval. This graph was drawn from negative pi over 2 to positive 3 pi over 2, right? But when we set up an interval, we get there at the end, but it had to have been 0 to 2 pi to begin with. So if I want to get this back to 0 to 2 pi, you would have to add pi over 2 to everything. So that'd be 0 less than or equal to x plus pi over 2 less than or equal to 2 pi. So my angle is x plus pi over 2. And then the plus 1 on the end to move up 1. Alright, so that's really the end of this section. I want to give you time to work. So this is your assignment. Both this and yesterday's will be due Friday. So tomorrow we're kind of recapping